Okay, so what we have here is a 5-volt 2-amp power supply, DC of course. I'm going to follow that line all the way around over to here. And what you can see here is I have some pixels. It's 25 total pixels, so 5 by 5. They're set up in a zigzag pattern. And we have our 12-volt power supply feeding right here. So the pixels are plugged in. We've got the 5 volts sent into the center there. There's another small wire set into the center there with that with the pixel power on the positive side. The negative side, the pixel power is being fed off of this white one here. Comes around, comes up to the injection wire on the back of the pixels. The other wire that's on the outside there is with red wire for USB power. So we're feeding that into this tan cable here. Comes around, comes down. That's just a standard USB connection to feed this micro USB cable, which is feeding our node MCU, otherwise known as an ES8266MOD. Now these adapters are roughly $10 or so, and you can use them for multiple different projects. The main brains of the system here are actually this tiny little chip right here, but this chip runs on 3.3 volts, whereas USB is 5 volts. So 5-volt pixel setup would be pretty easy to implement this. You could get a USB connection or just hardwire your wires into the power that you're injecting into the back of your pixels. With a 3.3 volt system, you're going to need some kind of a regulator to bring the 5 volts down to 3.3, and then you're going to want to filter it to keep it stable as well. Now, with this gives us wireless capabilities for E1.31, and that can be an absolutely amazing option for those display sets that you have that you want to put out in the middle of, let's say in the middle of your yard, on top of the roof or something, and you don't really want to run any cables. And here I'm just placing a napkin over that so you can kind of see the pixels a little bit better as they move. So now we're going to switch over to another view here. I'm going to go into a web browser. I have this with a static IP right now, 070. You could set that up as DHCP and just have an address assigned to it randomly. But to keep track of it, to get easy access back to it, you're going to want a static IP. So for here, I'm using 70. So we go into the testing option. Here I currently have it set as chase. I want to move that up to static, and I'm going to pick a color, and I'm going to pick red. Actually, I'm going to pick, oh, we got a little issue going on here with noise. So I'm going to pick red, and we're going to switch back to our camera, and we are going to see that that is now displaying as red. So there we go, red. A little flash there, but again, that's because I've got a little noise coming into the system here, so it's kind of interfering with the data line. So if I actually let go of this, you're going to see it kind of switches back to blue. And again, that's just, it's noise in the data line. If I cover this up a little bit, we'll see it starts performing well. So we want to keep this about a foot or two away from the actual pixels to keep that EMF down. So I'll switch back here real quick, back to the web browser, and we're going to come back into here, and we're going to switch this to chase, and we're going to pick a different color. So right now we've got green going. Let's switch that to blue, and we'll switch back and give you guys all a view here. So there's our blue going like it should. Now, of course, this is just manual control through a web page, but if you set this up in your xLights configuration with a static IP of, in my case, 192.168.0.71, I'm going to be able to actually control this with any of the elements that it's attached to via xLights. So I typically use xLights, create my sequence, put that out into a Raspberry Pi that's running Falcon Pi Player, and place those elements all on the same network, and then the Falcon Pi Player software on the Raspberry Pi actually controls all the elements out in the yard. So this being wireless would be fantastic, because then all we really need to do is supply 5 volts, and the rest is all handled via wireless connection. Now we try to keep this down, I believe they said 25 elements or less, so 25 of these devices on the same wireless network or less. There are ways to, of course, get that much higher, but as a starting point, 25 of these, we can do up to, I believe they said, 2 universes off of one of the ES Pixel Stick type devices, which essentially is this device running a ES Pixel Stick firmware on here, which can be modified, of course, as well. It's open source firmware, and basically run your show wireless. So anyway, sorry I'm rambling on here, but you get the idea. It's a fantastic option. Have fun out there.